So the difference there is the difference if you substitute x prime, which is higher for x. Think of a profit function. Yeah. The difference is bigger for the higher z prime, then that same difference is on the right hand side. You see the same difference, the difference between x prime and x, but now for the lower parameter. So suppose the parameter z is some technology parameter, then for a higher technology, if you choose x prime instead of x, then your profits increase more. The difference in profits is relatively higher for the higher parameter value and for the lower parameter value. That's what this is saying. Yeah. So the incremental gains to choosing a higher x, choosing x prime rather than x, is greater when z is higher. Hence the name increasing differences. And of course, it's submodular if the inequality is reversed, and it's modular if both supermodular and submodular. It's modular, yeah. Very nice, all of it. Now, what's the result that you have in general with supermodular functions? Suppose you choose this variable x. Yeah. This is something you can choose. Think of profits. What's the profits that you choose? The up and all choice x star z is increasing in z if the function is supermodular. Yeah. So whatever the parameter was that we were discussing, for a higher value of the parameter, your optimal choice is rising. That's what this is saying. If this thing is continuous and twice differentiable, then it's supermodular if and only if the second cross derivative is positive. Yeah. So tau square pi, tau x, tau z is positive. Now, you also have log supermodularity. What does that mean? Well, same deal here. The function pi of x and z is log supermodular if you take x prime higher than x, z prime higher than z. Now it's not the difference, but it's the product of these things. It's bigger or equal. You can rewrite this if pi is strictly positive. So there's a caveat here. Strictly positive. The pi is log supermodular if and only if the log of pi is supermodular. And we can then write the inequality in relative terms. Now, that's the part here, this inequality here. Pi of x prime z prime divided by pi of x z prime. So that's the ratio of profits, if we maintain profits as the frame of reference. The ratio of profits for the higher parameter value z prime, if we choose x prime rather than x, that relative rise in profits is bigger than if we have the same choice, x prime x, but now for the lower value of the parameter z, which is on the right hand side. Yeah. So the relative gain to choosing a higher x, choosing x prime rather than x, is greater when z is higher compared to above on increasing differences. And so it's very similar, but now it's the relative change instead of the absolute change. Now, if this thing is strictly positive, continuous, and twice differentiable, then it's log supermodular only if the cross derivative of the log of pi, tau x, tau z is bigger or equal than 0. So in that case, you can easily check it. Now, what holds if G and H are log supermodular, then doing G after H is log supermodular. They're also multiplicative and additive and preserved integration. So most of the things that you want to do with functions, you can do with log supermodular functions, and it works out fine. Yeah, so that's the general theory. Now, what do Costino and Vogel do in supermodular production. Suppose you have a large range of sectors, from 0 to 1 continuing, and the range of skills from 1 to 2, we range them from 1 to 2, not to confuse them with the sectors. Yeah. ASZ is how much output we have in sector Z using 1 unit of labor with skill S. Yeah. So how productive is skill S labor? And LSC is the units of labor with skill S allocated to sector Z. So how many workers do you use of skill S in sector Z? Simple notation. Now the output Y of Z, so how much do you produce in sector Z, is given by workers are perfect substitutes. You integrate over all the skills that you employ in the production function. Yeah, so ASC is how productive is skill type S. What is good? LSC is how many workers you use. You just integrate this over S. So you can have many different skill types to produce your good. And this indicates how much total output is. Depends on how productive a certain skill type is for your particular good. Yeah. Now, here's the log supermodular thing. If we assume that this ASC, this technology, is log supermodular, that means workers with higher skills are relatively more productive in higher Z sectors. So we sort of rank the skills. We sort of rank the sectors in terms of skill intensity and how productive these skills are. So it's an assumption, it's a technological assumption, and it argues that workers with higher skills are relatively more productive in the highest skill sectors. It's a very familiar assumption if you look at the 2 by 2 by 2 case that we are familiar with for Hexaoline, because then it says we have no factor intensity reversal. That's basically what this is saying. Now, V of S is how many workers you have of skill type S, and of course full employment means they all have to have a job. The integral was sum to how many of them have. Demand equals supply in each sector. In equilibrium, each sector uses only one type of skills, actually, given by the matching function S. So the equilibrium turns out to be a matching function that matches skill types with sectors. And you have a wage rate to help sort the skill types over the sectors. An explicit function if Boolean have preferences with taste parameter BZ. What does that look like? We'll look at America and China. We'll assume that America is relatively abundant in higher skill types for all types of skills. Yeah? So it's more skill abundant. What we then have is something like this. On the horizontal axis, we see the skill type from low to high, high skill. On the vertical axis, we see the matching function, so which sector C matches to which skill type. It's not hard to understand why any particular sector uses only one skill type, right? Here is a matching function A for America. So take any skill type S, like this, where the arrow is now. You go up and, where is it? No. No. Take any level of skills, say 1.5, go up, and then you see the rank of sector C associated with that skill type in the United States of America. Now, For China, you have in autarky a different matching function, and it looks like this. It's strictly higher than for the United States. Skill time. And the reason is that America is relatively more skill abundant, according to the definition that we just saw. So that means that the China matching schedule rises faster in terms of sector, and therefore the wage schedule has more income inequality in China than in the United States. Now that's in autarky, and if the two countries now start to trade with one another, then there's an equilibrium matching function in between these two extremes, because now we integrate the world as a whole. So the consequence is that there is rising inequality in the United States, because that function now becomes steeper, shifts up, and it's a lower income inequality in China, because that function shifts down. From an empirical perspective, that seems to be troublesome. We all think there's sufficient evidence that there's rising inequality in the United States, relatively higher rewards for high-skilled workers, but this suggests that there's lowering income inequality in China, and that for sure is not what happened. So in that sense, there's a problem. In terms of a general connection, and because we've now been looking at various explanations or relationships between the reward of high-skilled versus low-skilled workers, and whether that's based on technological changes or trade flows. Based on trade flows with offshoring part of the production process, with intermediate goods, general trade flows, and in general the outcome that you want. You can always construct a model that generates the outcome that you want. There is sufficient flexibility in terms of modeling techniques to ensure that if you observe empirically higher income inequality in both countries, then that's what you can get. So what we saw earlier, if it's higher in one and lower in another, higher in the sender country and lower in the receiving country, then you can construct a model that organizes that, and vice versa. In general, we can tweak more in the model process, and we have sufficient flexibility in terms of our modeling process to get the outcome that you observe in reality. And this is not one of them. It would be my argument, but it's a different matter. Yeah, that's the explanation for chapter 3 and 4. I'll have a short break and then we continue with the questions on burnout or brown. I'll turn it up for a second. Ten minutes, okay?
Yes. Good.